All right, let's see what we can do here. Car travels at constant speed. This means the car, well, meters per second means it's going to travel 1 meter in 1 second. And increasing the speed, nope, nope. We don't even know what acceleration is right now. It's got to be moves 10 meters every second. A rabbit runs a distance of 60 meters. What's the speed? Speed equals distance over time. The distance is 60 meters. Time is 20 seconds. 6 over 2, isn't that 3 meters per second? An airplane on a runway can cover 500 meters in 10. What's the airplane's average speed? Just been there, done that, right? 500 meters in 10 seconds. I think that's 50 meters per second. A car travels. What is the distance? So, speed equals distance over time. I've got to get distance all by itself, so let's do that. Bye-bye. This turns into D equals speed times time. The speed is 40 meters per second times 4 seconds. Now careful here, that seconds we can put over 1, so seconds goes away. My answer is going to be in meters, which is good because I need distance. 40 times 4, isn't that 160? I think it is. Alright, number 6 here. How much time? Well, speed equals distance over time. It turns into, we need time. So I gotta go T on both sides, T on both sides. That's an equal sign, believe it or not. Then I gotta go to S on both sides, so T equals D over S. I have a distance of 120 meters. I have a speed of 20. 20 goes in 6 seconds. Seconds is going to be the one I want. Meters is going to cancel. Got a little quick there. How much time? We just did this. Time equals distance over speed. Distance is 150. Got to know your units. And the speed is 30. Meters goes bye-bye. 30 goes into 150 5 times, so that's 5 seconds. Positive direction. To the right is positive, north is positive, west is negative, up is positive. So I think we got to pick that one. Negative direction to the right is positive, south is negative because think of the graph grid. West is negative and down is negative, so I think we got to pick that one. How far your ending point from starting point, we know that's displacement. A car travels 60 to the right and 30 to the left. What distance? Distance, we just add them up. 60 meters plus 30 meters would be 90 meters. Car travels 60 to the right, 30 to the left. Magnitude and direction of the displacement. So I started here and I ended there. Start, end. So displacement equals position final minus position initial. My final, if I went 60 out, would be 30. And I started, we'll say at 0. 30 minus 0 is 30 meters. It's a positive. It's to the right of where I started. Starting from the origin, I'm in 13 now. I'm going to go there. A car travels 4 east and then 7 west. I started at 0. Whoops. Undo. And then 7. What's the total distance? It's 4 meters plus 7 meters equals 11 meters. Oh, it's kilometers, sorry. Get a little carried away. 4 to the east, it's probably kilometers again, isn't it? 7 to the west, we'll say we started at 0. What is the net displacement? Well, if you think about it, this is 3 kilometers, and that's my ending point, and this is my start. So it's final minus initial. My final was -3 minus 0, because that's where I started, and that would be -3 kilometers. Negative would be west of where I started, because I'm on that side of the 0, and we say that's west. Alright, I'm getting a little... There we go. You run around a track, 400 meters. Distance is total, so it's 400 meters. Displacement is you start its position final minus position initial. My final, I was at the end, so I was at 0 meters at the end of the story. I was at 0 meters at the beginning of the story, so it's 0 meters. Which of the following is a vector quantity? We didn't talk about this, but I will in class. Time doesn't have a direction. It's just a number. It goes forward. You can't go back. Velocity, though, has a direction. Distance does not. Speed is not. Average velocity is defined as the change in over a period of. So we know it's time is one of them, but which one is it? It's a change in position over a period of time. So we have to pick that one. Distance is its own animal. Velocity equals displacement over time. The displacement is 60 meters to the right. And we did that in 20 seconds, so this would be 3 meters per second to the right. Average velocity equals displacement over time. The displacement is 60 meters to the left. And it took 20 seconds to do that. So this is 3 meters per second, you guessed it, to the left. So this one we kind of got to figure out where we start. So you put a 0 down. I started there. It's my origin. So we went... $60 meters, and then we went 60 meters back. So my final position, I would be at the origin again, right? Minus position, I'm trying to go fast and I get sloppy, I apologize. Equals 0 meters divided by how many seconds it took me, which is kind of irrelevant at this point. And it's 0 meters per second. I bet they do something different to us here. We go 60 meters. Since it's speed, I just care about the distance. And 60 back, which equals 120 meters total, and I did that in 50 seconds. This one I'm going to have to take out the old handy-dandy calculator and get 2.4 meters per second. No direction because it's just a number. Alright, average speed, so I need to know distance. Speed equals distance over time. Distance is 400 meters. Time is 80 seconds. You would think I could do that in my head, but I can't. It's late and I'm tired. That's 5. Hello. 5 meters per second. And since it's speed, we just leave it alone. Now they want velocity. We started at 0. We ended at 0. I think you can see where this is going. Displacement is 0. 80 seconds. My velocity is 0 meters per second. Speed, all I care about is distance and time. My distance is 160 meters in 60 seconds. You throw that in your calculator, you're going to get 2.7 meters per second. Speed doesn't have a direction. Alright, you know I love a good graph here. So there's no numbers on here, but you could just kind of put your own on here if you want. We could say that's 1 and that's 2. And that's 1, 2, 3, 4, 5, 6 seconds. You get the idea. And it says, how do you know the velocity is constant? Well, the velocity value does not change, because remember this is a velocity graph. Velocity value does not change as time changes. Alright, let's go to 27 here. The graph velocity versus time. Careful here. When is the velocity increasing? Well, it was 0 there. 1, 2, 3, 4, right? So 0 to 4. So in between seconds, that was weird. From seconds 0 to 1. And I think, well, then we got -1, -2, -3, -4. So that's 1 second, 2 seconds, 3 seconds, 4, 5, 6. It's getting faster from here to here. This is kind of next chapter. I put it on here just to freak you out. So in between 4 seconds to 6 seconds. It's a 6. It's also, when is it decreasing? Well, it went from 4 to 0, and that happened between 3 to 4 seconds. And when is it constant? I think down there and down there. So 1 to 3 seconds. And then that would be 5 to 6 seconds, because it's a horizontal line. Number 27 I just put on there to mess with you. Hope it worked. Bye-bye.